Welcome to a lesson with Dr. Powell. Let's look at an application of quadratic functions. Let's suppose that we have a quadratic function that represents a trajectory of something being thrown. Okay. Now, usually in these types of applications, don't worry about all the details when they write things out. Really, all they mean is they give you the function. So they basically just give you the quadratic function. So please, when you're looking at this and they give a lot of information, they just give you the quadratic function. And then what they want is they want you to be able to find the maximum. Maybe they'll even ask you about how far it goes. So for instance, what if we can just give anything here? In fact, why don't we just give this quadratic function, one that we already know maxes and mins for? So what if we have something like negative quantity, let's see, x minus 4 squared, and then we have maybe like plus 5. Then we can easily answer these questions. How high? So suppose that x represents time even, since sometimes in application problems, this would even be a t. And the question is, okay, how high does the object go when it's being thrown? Well, you already know what I already wrote this in standard form for you, where you can see the transformation. So you can already see that the vertex is going to be located at 4, 5. Now, if it wasn't written in this form, you would need to work out the details of how to write it in this form. Okay. But in this particular example, I'll just give it to you, but are plenty of instances when it won't be given to you. Okay. So we have 4, 5. So we know that the height is 5. So that's the maximum height of the object that's being thrown. And then you might also ask the question, okay, how far does it go? Well, you can look at this picture and see if this point, and think about this, if you were to draw this, where's this cross the x-axis? You just find out the distance between those. You could set this equal to 0 and solve and find two values. In completed the square form, it's actually rather nice. In fact, why don't we just add this to the other side? Take a plus or minus square root. And then add the 4 over. T is equal to plus or minus square root of 5 plus 4. So that means this point over here is 4 minus square root of 5. This one is 4 plus square root of 5. And if you want to find the distance between these 2 points, let's think about this. This is 4, and you're going that way, square root of 5. You're going this way, negative square root of 5. So guess what? It's actually the total distance that it travels is 2 square root of 5. Thanks for watching.